So now we'll continue on with some normal calculations, and here are some examples where you're given probabilities and you have to find some other stuff out. So, for example, you might be given mean and variance and a probability, but you need to find the actual value that it's less than. So what I would do is I'd do z is equal to a minus 30 over root of 16. Then I'd say that px less than a is equal p to z less than a minus 30 over 4. And that's equal to 0.8944. And now here's what, and we say that then this is equal to phi of a minus 30 over 4. If you remember in the last video, we talked about how phi literally means, okay, probably it's less than this z value in the standard normal distribution. And then when we have a function, we can inverse this. And so what this means is, if I just bring down this table of z values, we basically look for 8944 on the table and then give it the z values. Here it is. That's 1.25. And then a minus z would equal 1.25 times 4, which is 5. So a would equal 35. That would be inversing the normal there. Obviously, you may have to deal with greater thans, and also, so if it was greater than is 0.8944, then this would be 1 minus phi of that, and then this would become phi of a minus 30 over 4 would now become 0.1056, and then a minus 30 over 4 would become phi inverse of 0.1056. Now here's an important point I make. If the thing in the phi inverse bracket is less than 0.5, what you do is you say it's equal to negative phi inverse of 1 minus that, so 8944 again. That will give us negative 1.25. A equals 30 minus 8, so 22. I'm sure you can tell by now, but I seem to struggle with basic arithmetic. Oh, hang on, when I did that earlier, that's not 30 minus 8, that's 30 minus 5, sorry. That's 25. And the reason for this is because of, again, the symmetry of the normal distribution curve. Because if you're saying that the probability that this area is 0.1056, then this area becomes 0.8944, and because of the symmetry, if you just do the positive value of that, this area is 0.8944. So that's one thing that you might be doing. It's kind of like inverse normal. But the other thing you might have to do is either find sigma or mu, or both at the same time. So you might be given something like this, and then you'd have to do your z, which is 15 minus mu over root 13. Remember the root. And then you'd have to do all your p's, so something like this and that. So then you eventually get to phi of 15 minus mu over root 13 equals 0.75. And this is also another important note of these critical values. Sometimes you can use these. So the 0.75, you can instantly say that the relevant z value is 0.674. So that's... And then with some simple algebraic rearrangement, you can get that mu. And you could get the same question with sigma instead. Now, the final case that I'd like to go over in this video is when you know neither. So find both. And what will happen is you're given two probabilities and then you'll have to do all the calculations. So you'll do this and do eventually you'd get to that equals phi inverse of 281. I'm skipping over the working. In videos when I do practice questions, I'll be doing full working. And oh yes, this is less than 0.5, so we do this is 0.719, and then we do that, and 0.58, and I will just show you, go far enough to allow you to see where this is going, and then the other one is like 6.472 minus mu over sigma equals phi inverse of the 0.591. That's above 0.5, so we don't need to worry about that. Now, so far we've been getting things that are nicely in this table. Sometimes you may need to look over here to find your probability. And now hopefully you can see that we're starting to form some simultaneous equations. Literally, you've got simultaneous equations and solve them to get sigma and mu. Generally, in an exam, you'll get what are called modelling questions, so like real life examples, like the heights of men in an African village, or the waiting times and minutes for patients at a clinic, the masses of all the different pies sold at a market, all those things. It's just the same thing. Try to ignore the words and focus on the numbers. And obviously, I will note that even though these are continuous probabilities, when you calculate a probability, they may ask a discrete question. So like, say you calculate the probability of the mass less than 87 kgs is equal to 0.31, then it might ask you to say, okay, probability of 8 out of 10 having mass less than 87. And that's a binomial distribution question. Or in a sample of 200, how many will have mass less than 87, something like that. And just use your discrete random variables knowledge there. In the next video, we'll be working on approximations, which is the final bit for normal distribution.